Today we're going to look at a different form of linear equation. So up at the top, I'm going to give you a couple of reminders about what we've been doing. We've been using slope-intercept form, which is definitely the most common form that you'll use for our math class. And slope-intercept form, again, you may just want to make yourself a review note of this. Slope-intercept form looks like this. We've got y equals, you do have to know your slope, mx, and then we have whatever value our y-intercept is. So plus some value that's our y-intercept. So slope-intercept form, hence the name, requires that you know the slope and you know the y-intercept. We're going to work with a form today called point-slope form. And point-slope form is a different way of writing an equation that, hence the name, only requires that you know a point, any point, and the slope. You do not specifically need to know the y-intercept for this equation. So point-slope form looks like this. It's going to look like y minus some y value, some point that you have. So y minus y1, and that y1 is just from any point on your line, equals, we still do have to know the slope. It is called point slope, so we need the slope. So m times x minus an x value from the same point you used before. So we do still have, just like in our other equation, there is an x and a y that's going to stay in your equation, but we're substituting in the pieces that we need. These equations don't have to be simplified a ton. You can leave the parentheses. In fact, if you did distribute them, you would be getting the slope-intercept equation eventually. So you can do that, but you don't need to when asked to write an equation in point-slope form. So in example A, we're given a point and a slope and asked to write it in point-slope form. So we've got the point 4,1 and the slope 2. So in my point, I've got an x and a y. I'm going to call it x1 and y1, because eventually that will make a difference. And then my slope is my m in my equation. So now I'm going to take those pieces and I'm going to substitute them into my general form of the equation we just wrote at the top. So we would write this as y minus, and I'm going to put the value for y1, which we said we labeled that the 1 was y1, equals, the slope is 2, times x minus x1 we labeled was the 4. And that's it. That right there is your equation for example A. We don't have to do any simplifying. And again, if we did simplify, it would actually end up looking like slope-intercept form by the time we were said and done. There are a few things that we can neaten up when we need to, and we'll see that in these next two examples. So just like the last one, in example B, we have a point. We have the point -6, 0. So I'm going to call that x1 and y1. And again, those matching ones just mean they're from the same point. And then my slope in this one is 2/3. So that's going to be my m. So just like before, I'm going to substitute those values into my equation. So I've got y minus y1 is just 0 equals, the slope was 2/3 times x minus, and in this case, I've got a -6. I've told my class this, when I have minus a negative like this, sometimes if I'm writing kind of sloppy, it looks like one big negative sign. So I do like to put an extra set of parentheses around the extra negative that's in there, just so that I don't miss it. And I am going to clean this one up a little bit. So there's two kind of things I can do here. When I look on the left side, I have y minus 0. Y minus 0 is just y. Anything minus 0 is itself. So I'm just going to clean that up and get rid of the 0. That's fine to do. You can leave it, but it's going to make it look a little nicer. And then on the other side, the 2/3 is going to stay. I'm just going to clean up inside the parentheses. So instead of writing minus a negative, we know minus a negative is the same thing as adding. I'm going to put a +6 instead. And that is still in point slope form. It's just a little bit neater than it was. And again, you could leave it in the original version, but in theory, maybe you see this on something that's multiple choice, and we want you to recognize that you can clean it up a little bit. All right, last one like this, we've got, again, just an x1 and a y1 from a point, any point on the line, and then my slope here is -1. So we substitute those in to our general form. So y minus y1 is -1. I'm going to use those parentheses so I don't forget that extra negative there. Equals, my m is -1 times x minus, my x1 is -8. And again, using those extra parentheses when I'm trying to write double negatives. So I'm going to clean that up a little bit. The y minus -1, I'm going to change that to write it as y plus 1 because minus a negative does make a positive. When we have a -1 multiplied out front, you can leave it there, but a lot of times multiplying by -1 is just like multiplying by negative. The 1 doesn't actually change anything. So a lot of people will drop the 1. So I wanted to make sure you saw one like that as well in case you forget that the 1 isn't necessary to write. And then I do have an x minus a negative, lets me write that as +8. And that would work for my simplified answer. We don't have to distribute. We don't have to do anything else. That is considered point slope form. So now, here we were given a point and the slope. If we're given 2 points, we can find the slope, and then we have enough information to write our equation. So we're going to have to find the slope here first. So I'm going to label, in this next example, I'm going to label, I've got x1, and from my second point, I'm going to call that x2. I'm going to label my y values as y1 and y2. So this will be a nice quick little review of slope for you. So our slope we represent with an m. And when we do slope, we do y2 minus y1. So -1 minus 7 over x2 minus x1, which is 1 minus -3. There's one of those double negatives. And then I just have to simplify. -1 minus 7 is -8. 1 minus -3 is the same as 1 plus 3, which is 4. And -8 over 4 is -2. I'm going to simplify because I can. So now, here's where you get to make a decision. You get to decide which point you want to use. We only need 1 point, and it can be any point to go in our equation. So you just have to pick one. I usually pick the first one because I am a creature of habit, and I just almost always choose to go with my first point, but it does not matter which one you pick. You're still right if you use a different point, as long as you use the x and the y from the same point. So when I write up my, my point slope form, just like before, I'm going to say y minus, and I'm going to use that y1 value, but again, we could have picked the other point. It doesn't matter. So y minus 7 equals, we found the slope up here was -2 times x minus whatever x1 is, and in this case, that was a -3. There's one of those double negatives again, so I am going to clean that up a little bit. I'll write it over to the side. So I would write my answer here as y minus 7 equals -2 times x, and we're going to change that minus a negative, does make that a +3. And that would be a nice simplified version of my answer. Let's do another one together. So just like before, we're going to find the slope very first thing. So I'm going to label my points again. I've got x1 is -4, x2 is 6, y1 is 7, y2 is 2, and we're going to find our slope. So my slope will be y2 minus y1, so 2 minus 7, over x2 minus x1, which is 6 minus -4, double negative again. When we simplify that, we get 2 minus 7 is -5. 6 plus 4 minus a negative makes that +4 is 10. Both of these numbers are nicely divisible by 5 to simplify. So negative 5 divided by 5 is 1. 10 divided by 5 is 2. So my slope here is 1/2. So we'll use this slope, which is the slope for all points on my line. And then I'm going to use, again, I just stick with the first one. Creature habit, you can use the other point, and your answer is still right. So then when I write my equation, I'm going to write y minus y1. So in this case, I had another 7 for y1 equals the slope, which was, it should be a negative 1/2. I dropped my negative. Negative 5 divided by 5 was negative 1. So negative 1/2 times x minus, and in this case, I've got my x1 was a negative 4. So I'll clean that up just a little bit. Y minus 7 equals negative 1/2 times x. That minus a negative 4, I am going to write as plus 4. And that would be my equation in point slope form. So now this last problem, my suggestion to you is to pause and try it on your own. You have the point -6, -3, and -4, -1. So take a second, pause, try it, and then turn your camera back on when you're ready to check your work. So I like to label x1 and x2, y1 and y2, just to keep myself organized. My slope, I have to find first. My slope is going to be y2, which is -1, minus y1, which is -3. Lots of double negatives today. And then x2 is -4 minus x1 is -6. Now we simplify. -1 minus -3 is the same as -1 plus 3, which is 2. -4 minus -6 is the same as -4 plus 6, which is 2. 2 divided by 2 is 1. So my slope is 1. I'm going to use that first point again and write my final equation. So I'll write this as y minus y1. So in this case, that was a -3. I put that parentheses there just to not lose track of that double negative, equals my slope is 1 times x minus x1. X1 is -6. And then we'll clean that up. Y minus a negative is the same as plus 3 equals, told you that 1, when there's a 1 out front, a lot of times we just drop the 1 because multiplying by 1 doesn't change anything. So then I can say x minus negative would be the same as plus 6. And now that we actually, since we don't have anything outside the parentheses, you could even drop the parentheses if you wanted to. That multiplication doesn't make a difference there. So that's a quick little overview of point slope form. Again, it's not super common to use. We usually use slope intercept, and we learned already how we can write the equation of a line in slope intercept form. We can use the slope to find the intercept, but this is a nice little shortcut for you.